Manipulating user state. Summary. An attacker modifies state information maintained by the target software in user-accessible locations. If successful, the target software will use this tainted state information and execute in an unintended manner. State management is an important function within an application. User state maintained by the application can include usernames, payment information, browsing history, as well as application-specific contents such as items in a shopping cart. Manipulating user state can be employed by an attacker to elevate privilege, conduct fraudulent transactions, or otherwise modify the flow of the application to derive certain benefits. Attack execution flow. Explore. Attacker determines the nature of state management employed by the application. This includes determining the location, client-side, server-side, or both, and possibly the items stored as part of user state. Experiment. The attacker now tries to modify the user state contents, possibly blindly if the contents are encrypted or otherwise obfuscated, and observe the effects of this change on the application. Exploit. Having determined the information stored in the user state and the possible ways to modify it, the attacker can violate it in order to perform illegitimate actions. Examples: instances. Upon authenticating a user, an application stores the authentication decision, auth equals 0/1, in a cookies unencrypted. At every request, this cookie is checked to permit or deny a request. An attacker can easily violate this representation of user state and set auth equal 1 at every request in order to gain illegitimate access and elevated privilege in the application. Description. Analysis. The attacker observes contents of client-side user state variables, stored in cookies or hidden fields or query strings, and modifies them in order to observe their effect on the application. Solutions and mitigations. Do not rely solely on user-controllable locations, such as cookies or URL parameters, to maintain user state. Do not store sensitive information, such as usernames or authentication and authorization information, in user-controllable locations. At all times, sensitive information that is part of the user state must be appropriately protected to ensure confidentiality and integrity at each request. Attack motivation. Consequences. Technical impact, confidentiality, access control, authorization, gain privileges, and assume identity. Related security principles. Reluctance to trust. Never assuming that your secrets are safe. Related guidelines. Treat the entire inherited process context as unvalidated input. Use well-known cryptography appropriately and correctly. Purposes. Exploitation.